All right, here we go. Last submitted assignment for you for this virtual marking period for your freshman year. This is it. This, like I had said a couple of times before, remember, if you show completion in the fourth marking period, you will get the third marking period grade. So you just need to submit this assignment. You're good to go. Here we go. You need to graph this inequality. Y is greater than 3 over 2x plus 2. So we're going to start at 2. Our slope of 3 over 2 means I rise 3, run 2. I need to make a dotted or dashed line because of the greater than sign. The reason you do that, okay, in case you still don't know, is because any point on this line, and that's why you may have noticed my open circles, any point on that line is not a solution. If you were to pick the point 0, 2, 0, 2 is greater than 2. Well, no, 2 isn't greater than 2. 2 is the same as 2. So definitely need to have that dotted line. Then I need to shade above because I am greater than. There you go. Letter A is done. Letter B. Explain how you could use your graph. Okay, just your graph to determine if the ordered pair. I'm sorry, there should be an ordered pair there. I believe it's 4, 5. Because I think we kept it the same. How could you use your graph to determine if the ordered pair 4, 5 is a solution of the inequality? Well, when we go ahead, we would graph it. Well, 4, 5 is right here. So based on my graph, 4, 5 is not in the shaded area. You would check to see if it was in the shaded area. That's how you would check. That's how you would use your graph. You would check to see if it's in the shaded area to determine if the ordered pair is a solution. It's not, so it is not a solution. Now, determine using algebra, okay? Letter C says to use algebra. Well, using algebra means I gotta use some numbers. I'm gonna plug in 4 and 5. Here's my original inequality. If I plug in 5 for y and 4 for x, one and a half times 4, 6, plus 2 is 8. Is 5 greater than 8? No. So that's how you would use algebra. You would plug it in and you would check. That's a false statement, not a solution. And so you can see our answers to whether or not it's a solution match up. Number 2. Here's your system. Which one of these matches? What's nice is I can easily get rid of B and C. These two signs mean that it's going to be dotted lines, solid, solid. These are only 2 that are dashed. And you can actually see that the region is shaded in the same place, above the one line, below the other line. But what you see is actually one of these lines is graphed incorrectly. All right, looks like we correctly graphed the bottom line with the down 2, right 1 slope. That's graphed correctly. It's this other line that should be down at a -6, up 1, right 1. Definitely letter A. Process of elimination. There's other ways to figure that out. You could have plugged in points, kind of like we did on letter C on the front page there. Find different answers. But because all of these regions are about in the same area, that's definitely not one of your most efficient ways to do it. I think just doing what I did is the best way. All right, we got an inequality, a system to graph. So we got to graph both lines starting at -1, up 1, right 1. I'm gonna grab my ruler here quick. So that is the top line, and I do like to shade it ahead of time. So I'm gonna shade this, I'm above that line. So lightly I'm gonna say I'm above that line. bottom line starts at a positive 3, down 1 to the right 2. So that looks something like this. So hopefully your graph is similar. Both solid lines because of those greater than or equal to's. This graph I'm also above, and now you can already see. Not shaded at all. Shaded once, shaded twice. Here is my final shaded region. So then the last question, similar to on the front page, and you can do this however you want, but is 215 a solution? When you have the graph, I think the easiest way is to graph it. 215, somewhere up here. This gets people every year. They say, well, no, it's not in the shaded region. Well, come on, guys, remember, these lines go forever. This graph goes forever. This shaded region goes forever. That is in the shaded region. Yes, it is a solution, definitely. All right, last two questions. Here we go, we got Tyreek here. Always leaves a tip between 8 to 20%, nice. 8% a little low, but everyone's their own person. This would definitely represent it if X is the cost of the meal. You would multiply by 8%, multiply by 20%. You want to be less than 20, above 80. This is definitely true. I mean, you could make like a rough sketch of this. One of them has a real flat line, another one a little bit more, and we need to be less than. And so you got like all these possible tip amounts based on your money, but that's not the easier way to do that. Easier way to do this, multiple choice. Plug it in and see. If the cost of the dinner is $10, well, we would take 8% of $10 and we would say, if the dinner, first of all, dinner that's only $10 is kind of cheap. And so to give them only an 80-cent tip, it kind of makes sense. The amount of tip between $2 and $8, no, right now it says that it should be more than 80 cents. And just to check, if I plug the other one in, it's between 80 cents and $2. So letter A is wrong. Letter B, I'm doing the same thing. The dinner is 15, so 15 times 0.08 is 120. Okay, so I need to be above 120. 0.2 times 15 is $3, so I need to be between 120 and $3. You gotta believe that B is right. You can continue to go through. These are a little bit harder. You're actually working backwards. It says if the tip was $3, then the dinner must have been between 11 and 23. Well, you can plug in 11. And if I had an $11 meal, then my tip would have been 88 cents. And it says that when the tip is $3, that's definitely not true. The other way you could find that is if I plug the 3 in for Y and divide by 0.08. Well, if the tip was $3, see how that's a little off, right? So definitely not right. Letter D, if the tip was $2.40, the dinner must have been between $3 and $6. Remember when we checked this one, the dinner was 10 and the tip was 80 cents? There's no way a $3 meal would have a $2.40 tip, especially with this kind of math. Okay, between 8 and 20%, 8 and 20% of $3 is not $2.40. Letter D has to be wrong. All right, last question. Quite honestly, this could have been difficult. It's one of my favorite questions when we're in class. We haven't been in class, and so your understanding of systems of inequalities might be a little bit worse than it would have been, obviously, than if we were in class. But this question really shows me you know what you're talking about. You know pretty much everything from this unit. I need you to write 2 linear inequalities, and they have to satisfy these 4 things. There are hundreds of different answers. When I grade this on the actual test when we're in school, I just go one at a time, and you can see I make these like little check marks. And if you get 4 check marks, you get all 4 points. You lose one, you lose a point, and things like that. Okay, it's the easiest way to check it because, like I said, there are an infinite amount of ways to do this. So what I'm drawing, there's a good chance you don't have, but you want to kind of follow along and see the same thing I'm doing, okay? So it might not be easiest to do this in the order the directions say. I kind of try to work backwards. If negative 1, 3 is a solution, negative 1, 3, that's a solution. That means that that point better be in the shaded region. But if 4, negative 1 is not a solution, then this point, and I'm going to put an X over it, should not be in the shaded region. So I somehow have to create a shaded region that has this half of the graph, but not this half, or that half, and not this half, or the left half and not the right half. So you can start to see there's a lot of different ways to do this. You can be creative. One of the lines can't be diagonal. Well, that would be easy. What if I just make a line, a vertical line, that splits them in half? That would satisfy this requirement that one of the inequalities can't be diagonal. Well, this one won't. It would satisfy that that's not a solution, and then that this is a solution. And then I would just have to make sure that one of them is strictly greater than or less than. Well, I can do that right now. Let's make this one just greater than. Or I'm sorry, this is going to have to be less than. So I'm going to make this vertical line at x equals 2, which means I'm going to have this inequality. X is less than 2. Because if I have x is less than 2, that gives me this region, which does everything I need to, except for the fact that I'm supposed to write 2. I've only written 1. So I need to draw another line that will keep the shaded region over in this area. It would be possible I could draw a diagonal line that goes like this and shades both sides. That's fine, because remember, the system of inequalities, to be a solution, you've got to satisfy all. So, easiest way to do this, I'm going to draw a diagonal line that goes right through the origin. That would be y and x, right? And then I'm going to shade above it. So I'm going to say y is greater than or equal to x. That would give me this line. That would tell me that that's a solution. That would not allow that to be a solution. All 4 are satisfied. I got the right answer. Thanks for tuning in. Thanks for doing your work all year. If you haven't done your work, you've got till June 1st to finish it up. If not, have a great summer. See you next year.